Hello everyone, welcome to our session second of permutation and combination. Here we are discussing the important concepts and problems which are relevant for the students who are preparing for CA foundation exam. So guys, so far when it comes to the concept of permutation and combination, I have introduced this topic with the concept of factorials. We have discussed the concept of factorial here, and after discussing about after factorial we have discussed about the what is the permutation and what is combination. Okay, we discussed the formula of combination and permutation. So basically, when it comes to solving questions, you can solve question by basic mathematical calculations, but when it comes to the actual problems where you need to use the advanced concept of counting, you need to have a basic knowledge of permutation and combination, the formula permutation and combination, and based on the formula we have done numericals. Okay, we have done numericals for this. Like in the last session, I have discussed till question number 10. I have done numericals till question number 10. I believe you have seen the first part of the video where I have discussed these numericals. Now, in this session, we'll go further of our discussion of numericals, where from this exercise one we have done 10 questions. Now, in this session, we'll continue discussing the further numericals after this. So now discussing about this, now question number 11, if you see, so if you solve this question number 11 step by step, then it would consume a lot of your time. The better logic it would be if you can use the concept of options. If you're using options, it would be easier for you to solve the question. Okay. So like if you see this 56, when I'm seeing something like xp2, if it's 56, so the first thing what is coming in my mind when I'm seeing this number 56, it is basically 8 into 7. Okay. And when I'm seeing the next term is 30, so suppose yp2 is suppose 30. So when I'm seeing 30 means what is coming in my mind is 6 into 5. Okay. So if I'm not wrong, then my x is 8. If I'm not wrong, my x is 8. Okay, you can try randomly or you can use option. My x basically means m plus n. M plus n is 8 and m minus n is basically 6. So if I solve this, 2m is equal to 14. So m is my 7. So if my m is 7, okay, then uh, I m plus n is 8, so my n would be equal to 1. Okay, I don't know I'm correct or not correct. So if I'm correct, then this would be your answer. So in that case, if m is 7 and n is 1, then m plus n means 8p2 is 56, correct? And then 6p2 is 30. Okay, so this would be your answer. Okay, if you go with option A, so 6 minus 2 is 4. 4p2 is 12. It's not 30. If you go with option C, then m minus n it would be 0. So C anyway cannot be answer. So the answer for question number 11 is option B. Then question number 12 and 5 PR is 60. So 60, how will you get 65 into 4 into 3? Okay, so this will give you 60. So okay, so if you start with 5, 5p1 means 5, 5p2 means 20, 5p3 means 60. So means what is your R? R is 3. Okay, then if you see question number 13, here also you use the same logic. When I'm saying 132, 132 means 12 into 11. If I'm not wrong, 12 into 11. So and then this is 6 into 5. Okay, so it means n plus 1 is 12, n1 plus n2 is your 12, and n1 minus n2 that is equal to 5. So your n1 it would be equal to 18. 18 divided by 2 is 9. Your n1 is 9 and n2 would be equal to 3. Okay, so option C if I'm not wrong. So let me try. So this is now if I try this 9 minus 3 6, 6p2 is 30. And here, so this would be answer. A cannot be answer. And this B, option B, 8p2. 8p2 is 8 into 7. It cannot be 30. So this also cannot be answer. Then question number 14, the number of ways in which letter word computer can be rearranged. So the number of ways how you can arrange the letter word computer, it would be 8 factorial. And how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. Okay, but they are asking rearrange. So rearrange means basically you will not use the same word. That is rearrange. Arrange means it would be 8 factorial. Rearrange means the whatever this computer is written, right? So you cannot use the same word. That is what rearrangement. 8 factorial is 40320 minus 1. So if you do this, your answer is option B. Okay, next thing, next question. The number of arrangement of the letter word failure so that the vowels always come together. So in failure, how many vowels are there? In failures, if you count the number of vowel, how many vowels are there in failure? So in failure, you have A, I, A, I, U, E. Four vowels are there. And how many consonants are there? F, L, L, and then R. Correct, right? So there are three consonants are there and four vowels are there. Suppose these four vowels make a letter X. So now you have total how many letters? F, L, R, X, where X is all your vowels. So in how many ways you can arrange this? 4 factorial into. Now the X consists of four vowels which you can arrange in 4 factorial way within the itself. So 4 factorial is 24. So 24 into 24, 24 square, it would be 576. So the answer for this question, it would be 576. Okay, going further, 10 examination paper are arranged in such a way such that the best and worst paper never come together. Best and worst never come together. So here the same thing it came in N also. Same thing. So your 16 and 17 is same thing only. So let me first do 16. So you have like total you have 8 papers. You have 8 paper plus you have best paper plus you have worst paper. So total 10 papers are there. Okay. So now let best plus worst, best plus worst paper make it equal to X. Okay, because they should be together. So so then you have how many papers? You have 9 paper. You have 9 paper. Now you have 9 paper. You have in that 9 paper, you have 8 paper plus X, where X consists of best and worst together. Okay, so in how many ways can you arrange this? You can arrange this in 9 factorial into 2 factorial way. Okay, so the best and worst they can interchange their place, right? But they would be together. So they you they like they always together in 9 factorial into 2 factorial way. And in how many ways you can arrange the 10 paper? 10 factorial way. So imagine if they would have asked that they are always together, then the formula for that would be n minus 1 factorial. Like imagine if they ask you always together, the answer would be n minus 1 factorial into 2. That would be the formula in the term of n. Always together. Okay, and here they're asking never together. So never together means if they're asking you never together, if they're asking you never together means total ways. Never together means total ways minus always together. Okay, always together. Never together means total ways. Total ways is 10 ways, 10 factorial minus. Always together means 9 factorial into 2. Okay, so here you 10 factorial you can write as 10 into 9 factorial minus 9 factorial into 2. If you take 9 factorial common, you will get 10 minus 2. So the answer for that would be 9 factorial into 8. And the answer would be 9 factorial into 8, option C. Option C would be your answer. Clear everyone? Okay. Now same thing if they ask you in the term of n, same thing they ask you in the term of n, then what would be answer? Total number of ways in the term of n, it would be n factorial. And always together it would be 2 into n minus 1 factorial. Okay, so you can take n minus 1 factorial common. You left with n minus 2. This will be answer. N minus 1 factorial into n minus 2. N minus 1 factorial into n minus 2. 17 answer would be option A. Clear everyone? Okay, now we'll try this 18th. So we have done till 17 question. I hope you have understood. Nobody have any doubt. Now we'll discuss from question number 18. So talking about question number 18, the 12 school teams are participating in a quiz contest. Number of ways in which first. So you can give first position to any of the 12 student, but whoever got the first cannot get second, and whoever got second cannot get third. So this is basically 12P3. Okay, so the answer for this is 1320. The answer is option B. 18th, the answer is option B. 19th already I have done in the previous video. You can go through that. And already we have done. Now question number 20. Question number 20, the number of four-digit number greater than 5,000. So greater than 5,000 you want to make. So four-digit number you want, right? So in this place, only 5 or 6 can come because you want greater than 5,000, right? So either 5 can come or either 6 can come. And 2, 3 other digit lesser than 5 cannot come in this place because then the number would become lesser than 5,000. So now, so you have used one digit. Now you have three digit which need to place in three places. So the answer for this would be 2 into 3 factorial. 3 factorial is 6. So 2 into 6. Okay, okay. Sorry, one more digit is there. How many digits are there? 3, 4, 5, 6, and 7. Okay, so four digit. Okay. So here I have not seen the 7. So here 5 can come or 6 can come or 7 can come. So any of the three digit can come here. Okay, now you have three places where you have used one digit, right? I have used one digit. Suppose I have used 5, suppose. So now I have 1, 2, 3, 4, and you have three digits, three places, and uh, four digits. Any of the four digit, but the places are three. So that can be filled in 4P3 way, and the first place any three digit can come. So 4P3 means 4 into 3 into 2, 4 into 3 into 2. Okay, 4P3 means 24, right? 4 into 3 into 2, 24 threes are, it would be 72. So the answer for this would be 72. Question number 20, answer is option A. Okay. Now next question, 21. Four-digit number formed from the digits as a number. Okay, four-digit number you want to make, right? Four-digit number you want to make. Okay, so 0 cannot come here. So total 1, 2, 3, 4. So 0 cannot come. 1, 2, 3, 4. Any digit can come. Okay, so any of the four digit can come here. Now you have three place. Okay, suppose I use 1 and then you have 1, 2, 3, 4. So out of four digit, you have three places. So in how many ways you can do this? So this would be 4P3 way. So 4 into 4P3. 4P3 is again 24. 24 4 this would be 96. 24 4 it would be 96. So the answer for this 21 is option C. Clear, because you want to make a four-digit number, right? But the digit, how many digits are given to us? Total five digits are given to us. And out of these five digits, 0 cannot come in the thousand place. So in the thousand place, any digit can come, either 1 or 2 or 3 or 4, that is not matter. So in the thousand place, you can put any number, and that can be done in four ways. Then you have three places left, and total you have around how many digits? Total you have 4 digit left. And from 4 digit, and but the place for them is only three place. So from 4 digits, you can choose any 3 digits that would be done in 4C3 way. And then those 3 digit would be arranged in 3 factorial way. So that is 4P3. So the answer for question number 21 is 4 into 4P3. And the answer is 96. Clear everyone? 4P3 is 24, 24 4 is 96. Okay, then question number 22. The number of ways of the letter of word triangle would be arranged so that the angle will always present. So angle, let this suppose x. Angle is suppose x. So this no arrangement would be done. So it would be always angle. So now when it comes to triangle, triangle is not a triangle, it is TRI. Okay, and then angle TR, suppose they is equal to x. So you can arrange in how many ways? 4 factorial way. And so the answer for that would be 24. And x cannot be rearranged because you want angle. You don't want any kind of arrangement between themselves. You want the first place should be A, then N, then G, then L, then E. Okay. So then question number 23, if you see, if the letter or word daughter arranged so that the vowels occupy odd places. So daughter is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So daughter is 8 letter word. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then how many vowels are there? Vowels are A, U, E. Okay, A, E, I, O, U. Okay, A, E, I, O, U. So here three vowels are there only. So the consonant it would be 5. Okay, okay. Now, if the letter word daughter are to be arranged so that the vowels always occupy the odd places. So how many odd places there? One, two, three, four. Four odd places are there, and I have three vowels only. So the three vowels in four odd places can sit in how many ways? 4P3 ways. 4P3 is 24. And then what they're asking you, then you have used three vowels now. Suppose I use the three vowel are A, U, and suppose E. Okay, now how many places left? One, two, three, four. Four places are there, and you have one, two, three, four, five. One, two, three, four, five. Total, you have five consonants. Okay, these five consonants can come in any of these places. One, daughters, 1, 2, 3, 4, 5, 6, 7, 8. So this is okay. So I have one, two, three, four, five. Five places are there, five consonants are there. So five consonant in five places would sit in uh, 5 factorial way. Okay, everyone. And then 4P3 into 5 factorial. 4P3 means 24 and 5 factorial is 120. So you can write this as 12 into 2 into, so 24 means 12 to the, so uh, this is 12 into 10 into 12 into 2. Okay, so you have uh, 12, 12 into 12 is 144, 2 is 288, 2880. So first, there are total four odd places are there, but I have only three vowels. It's like four chairs are there and three persons are there. So the three vowels can come in out of four places. The three vowels can come in those places would be done in 4P3 way. and then you have five places left, and 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 then because of five places and five letters, we can put them in 5 factorial way. So your answer for that would be 4p3 into 5 factorial means 2980. Clear? So I hope you have understood this. So we have so far done 23 questions. So this much questions are there in the first exercise. So because next class when we'll do, we'll start fresh with exercise 5B. So this much from the exercise 5A. So it's time to wind up this session. Thank you everyone. I'll see you all in next video. Bye everyone.